Hello children, you are watching the second video of the chapter Computer System. In the first video, you learned a lots of new terms and terminologies. For some it may not be new, but for others it is new. Data, information. Difference between data and information, computer and computing. The advantages and disadvantages, the different functionalities of a computer. Now we are moving on to evolution of computers, or here we are going to learn a lot of new terms. Now these terms are entirely going to be new for everyone. So for some it is difficult to remember the terms, isn't it? But you need to write and learn if you have the habit of forgetting it soon, because this chapter carries 10 marks for your annual examination. So without wasting time, let's move on to the chapter that is Computer System, Evolution of Computing Devices. The first word, abacus, that's not that unfamiliar to you, because you know this is a mathematic tool which is used even nowadays for learning the basic operations of maths. Addition, subtraction, etc. For some it may be difficult in the initial, but I know that if you learn with abacus, addition and subtraction, even with very big numbers, 9-digit numbers, will be very easy for you people. And for those who have not seen that, I have a picture of it, and this is it. There may be many pictures. If you want, you can Google and see. One such is over here. So back to our class. Here, this device was first developed by Egyptians in the 10th century, but this final shape it is given by, of course, the Chinese. Okay, that is not very important, but the first mechanical calculating device is known as abacus, is of course very important. So subtraction and addition can be performed very easily using this device. Okay, next comes Napier bones. John Napier, another mathematician of Scotland, he invented this, and that was actually made with the bone rods, and for that you need addition, subtraction, multiplication, and even division was being done with the help of the numbers printed on these rods. Well, the exact usage is not known to us because we are not very clarified with that, or we have no idea how they use it, but still a picture is very clearly given here. So the usage, of course, if you wanted to know, we need to Google further. So this is how it is given. So see, the numbers are found here. So maybe the multiplication, division is performed by changing the order like this. So this is something which I got, which lots of pictures are there. The most convincing picture which I found was this one. Okay, so let's move on. So not this, you have to go up. So Napier. So what is this difference between Napier bones and abacus? Napier bones is another calculating device, but through which you can perform addition, subtraction, multiplication and division. 1 point. Second point, it uses bone rods for counting purpose. Okay, where the number is printed on these rods. Then you have the Pascal's computer. The Pascal's computer, the Blaise Pascal, that is also another mathematician. When I say mathematician, the one who works with, the scientist who works with maths-based calculations. He invented a calculator, an addition machine, if you want, you can say. It's called Pascal's calculator, which represents the position of digits with the help of the gears in it. Again, I have the picture of that, so you can have some ideas. See, once again, what was it? It was this one, which represents a position of digits with the help of gears in it. So you can see some gears and some numbers are plotted on each. So with the help of the gear movement over here, it performs any calculations with bigger numbers inside this. So these were the evolution from where the concept of computer came. But one thing you have to keep it in mind is that your computer never had the option of storing anything till the storage program concept came, and that was invented by somebody called as von Neumann. VONNEWWMAN. Now The scientist called us von Neumann thought like if everybody can calculate, and calculator was invented in a much full-fledged manner. And I hope you all have seen the most the most modern scientific calculator. But what's the drawback? The answers are not stored there permanently. So that storage concept of how you need to store your data permanently, that concept led to the invention of a modern computer. Let's go back to our discussion. So Pascal's calculator was invented. Soon after that, the next one was Leibniz's calculator. Okay, another one, another mathematician. Its full name is Gottfried Leibniz. Modified the Pascal calculator, and he developed a machine which could perform various calculations based on multiplication and division, as well as your addition and your subtraction. That means at a time several calculation was possible there. So let's see the picture of it, and this is how it is. See, that was modified into another way, and this is how it looks like. So the particular turning machine or turning tool is here, with the help of which they might be adding more numbers to it, and the calculation might have take place. So that's your Leibniz calculator. Now you have your analytical engine. Now from here onwards, that stored program came into being. Okay, even though here in this section it is not mentioned, his name should not be forgotten. The von Neumann, he is the one who introduced stored program concept. So using that, we call him Charles Babbage, as the father of computer. He invented what we call as the analytical engine. There, the data was kept permanently. Data was kept safe. As we know, even now, the smallest storage device called as chip, you can store your data in a chip. That time, the biggest machine which was ever invented to store your data permanently was by Mr. Charles Babbage. So when you have this concept, see, it's here is given one of the ideas which went a long way in making computers that there are today is a stored program concept, and he designed in such a way that we can think about storing it in one place. But the only thing is that this machine, we called it analytical, it occupied a room. See, much bigger versions are there. So one such is taken from a museum from Germany. So this is the machine, so much of calculation, and I think the answer will be somewhere printed over here using a paper. So all the data will be stored somewhere here. This is maybe a CPU of the old style. So this is your analytical engine. First computer designed by Charles Babbage. So that's a point to be kept in mind. Now you have Mark I computer, that is the next version. Now that was, of course, there was an IBM, International Business Machine Corporation. They actually elaborated this. I have to move on. They actually elaborated this, and the fully automatic machine which uses electrically actuated switches called relays, and this is how it looks like. We don't have to worry about how the working process is, but this is slightly different from an analytical engine, isn't it? So when you learn how do you differentiate, differentiate on the basis of the points given over here. Like this introduces stored program concept, which one? Analytical engine. This also has a stored program concept, but it uses electrically actuated switches called relays. Okay, so both having the similarity over here. Now next one, that is ENIAC. This in your smaller classes may be in 7th standard or 8th standard. 7th, of course, you might have learned in your computer textbooks ENIAC. Now from here onwards, of course, you have to elaborate and expand the form. ENIAC stands for Electronic Numerical Integrator and Computer. The development of vacuum tubes, that is the main point. That is, the storage system has been developed in the form of vacuum tubes and made it possible to build better computer. So this was constructed at the Pennsylvania University to satisfy the military needs. This marked the beginning of the development of the modern computers. Okay, the next one, EDSAC. Now again, to expand, it's called Electronic Delay Storage Automatic Calculator. Now ENIAC and EDSAC definitely can come to expand in full form manner, so expand the full forms and all. So it's especially give importance to that. Electronic Numerical Integrator and Computer. The next one is Electronic Delay Storage Automatic Calculator. The first full-size stored program computer built at the University of Cambridge. Okay, for what purpose? To provide a formal computing services for users. This was built according to the von Neumann. Now you understood now why I was saying that von Neumann's name in between. This was built according to the von Neumann principles by the Hungarian American scientist John von Neumann. But then this much of there is not there for you to write it down when a question comes. They can possibly ask you what is the difference between the ENIAC and EDSAC. You can say for what purpose ENIAC was developed and what purpose was EDSAC standing for. So the storage of this, consisting of the permanent storage. The first, of course, Charles Babbage came with the analytical engine. The next two is ENIAC and EDSAC. That way you can say. And the stored program, the full size stored program is EDSAC, and you should see EDSAC also, right? And this is it. Yeah, little bit bigger than the other one, isn't it? See, this occupied, of course, again the full room. I suppose this may be the processing unit, and then this may be the answering section. So we need at least 2 or 3 people to manage it. See, yeah. Now, after this, actually they're not in this section, they are not talking about any other computer. It is after your EDSAC, the desktop computer, the concept of what you see nowadays, the desktop computers. Of course, the old versions are very different from what you see now, but still we had that concept of desktop computers came into being. Slowly it moved on to the different varieties of computer, types of computer, multitasking computer. Supercomputers were developed. Now what is a supercomputer? They are not the normal one which you see over here. It is mainly meant to storage bulk amount of data for scientific purposes or for the government purposes, especially for weather forecasting or for the military's usage. Definitely a secretive section will be there. Now in that way, the first supercomputer developed was CDC. Okay, Control Data Corporation. Only had a single CPU. You should know what is CPU, Central Processing Unit. So the size was very small. That was the main point. When you develop it, it should be something compact in nature. And see, we call it as the performance was based on how it operates. So it had a peak performance of 3 million floating point operations per second. Means that we call it as flops. See, this floating point operations per second is called as flop. So that determines how much of speed is there for a supercomputer. So that was the first one developed. The speed was up to 40 megahertz. So for you have to just say the first supercomputer developed with CDC 6600, which had only single CPU and the size was fairly small. This completes your definition part. And the picture goes like this. So you might think, oh my god, this is small. Yes, this is small because they have a lot of processors are there. Okay, see. Next is our own. India's first supercomputer was developed by CDAC in 1991. Okay, and what was the purpose of using? Same thing again, for weather forecasting, for the military purpose, and for government's secret purposes. Okay, we'll see our param here. Yes. All right. This is how param's processor looks like. Okay. And param, you know what is the meaning of param, isn't it? If you don't know, param is supreme in Sanskrit, and that is how it was developed. So param, see, a series of supercomputers designed and assembled by Center of Development of Advanced Computing, and param means supreme here, and the need was, as I told, for weather forecasting, bioinformatics, and research in space, and for seismic data analysis. So if they ask you what is the use of param, which is the first supercomputer developed in India, answer is param 8000. After that, Paramuva, so many came, okay? So that's it, supercomputers usage. And now the last one, that is your the last of its kind. In between, so many other, we are not very concerned about such, so many things. Of course, if you need more data or more information regarding this, I am ready to explain it, because our main purpose is to go to your programming language section. So if this chapter is interesting for you and you need more explanation apart from the current syllabus on this, definitely you can always ask me. I'm here to point it out. Like suppose if anybody wants to know what exactly is the difference between how does it works in a supercomputer or in a desktop computer or in a multi-purpose computer, multitasking computer, so many are there. So if you want to know, you feel free to ask during our Google Meet, okay? But as per the syllabus, we can restrict it to this much only. So from the first supercomputer, we are moving on to the last supercomputer developed here. It is Pratyush. Actually, I should say Pratyush and Meher. Both. They are the fastest supercomputers now running in India. Maximum speed of 6.8 petaflops. Now you know what is the meaning of flop. That is floating point operation per second, which determines the speed. So 6 point peta. Peta is the highest, like gigabytes, okay, terabytes, petabytes we say. So that much is the style of storage over here. The speed is also quite, fast, and the total cost is over here for 38.9 crore. And to see, this is it. The processors, okay, are shown here. Of course, the monitor will be small, the processors is going to be big, and that completes your different versions of computer. So evolution of computing device, we started with Abacus, Napier's boards, Pascal's, Leibniz, analytical engine, Mark 1. I didn't say, did I say Mark 1? Of course, when I showed Mark 1, I don't know whether I made a mistake, because I showed analytical engine and I showed Mark 1. So if you have a doubt regarding that, just to show you whether if I, this is also Mark 1's another one, okay? And these two are analytical ENIAC and EDSAC things, okay? Yes. So if having a doubt, you can always check it out with me. Anyway, the picture and all is not that important. I just showed you so that you can develop some interest to see what was the kind of systems we had in the initial stage. And after Mark 1, of course, we had your ENIAC and EDSAC, then CDC, then Param, and then Pratyush. Okay, no? Yes. So this is it. Clear? So we are going to complete this section today, and with these two videos now in your hand, of course, you have to start your work. Okay, so I'll be forwarding this to you at the end of this session. That means when I complete the full chapter. So by the time, I think this videos are enough for you to learn your chapter properly. So I hope you understood everything, and let's make a conclusion. Thank you.